I'm here in front of you to present my choosing different word problems about applications of differentiations of derivatives to our real life settings. So the topic for today is derivative. What is derivative? So the derivative is in mathematics, the derivatives of a functions of a variable measures the sensitivity to change of the function of value with respect to a change in its arguments. So I will give you a problem. So the problem number one. So the radius of a sphere was measured to be of 62 centimeter. The possibility of error in measuring its radius is no more than 0.005 centimeter. Find the maximum possible error in the volume of the sphere if we use this value of the radius of the possible error. So here's my solution. Beside, we find the volume of the radius of a sphere, which is we use the formula of the area is equal volume of a sphere, which is pi radius square. So the equivalent of pi is 3.14. The volume of the sphere is given by the following formula, which is the volume is equals to 4 divided 3 pi radius square. So we will calculate the derivatives of the function like this. So derivatives of volumes is divided to derivative of radius is equals to 4 pi radius squared. After the derivatives, we can easily calculate the differential like this. Derivative of volume is equals to 4 pi radius squared the derivatives of radius. So now we will substitute the volume of radius r equals 26, which is in the radius of a sphere was measured to be 62 centimeter. And possibility of error is derivative of radius is 0.05 centimeter, that measuring its radius is no more than 0.05 centimeter. So, in the above equation, to get the maximum possibility in the volume of the sphere, derivative of volume is equals to 4 copy phi r squared, then the derivative of radius, which is the 62, and is squared by 0.05, which is the possibility of error. Then derivative is equals to 4 4 times phi r squared, which is the phi is equivalent to 3.14. So 4 times 3.14 is 12.56 times, because of 62 square of 2, which is 62 times 62 is 3,844. Then copy the 0.05, which is the possibility of error. So the derivative of volume is equals to 241.403 centimeter. Hence, the maximum possible error in the volume of the sphere is 241.403 centimeter. We found out this. And my second problem, or problem number 2. Calculate the absolute and relative error made when calculating the volume of a sphere of 12.51 millimeters in diameter, measured with an instrument that shows a thousandth of centimeter. So for this question, we should find out the thousandth of centimeter of being measured with an instrument. So let V is equal to volume, this is phi, and R is for radius. So the solution, the volume of a sphere is given by the following formula, is which is same as from problem number 1, is volume is equals 4 divided 3 pi radius cube. Then we will calculate the derivatives of the functions like this. Derivative divided derivative of radius is equals 4 pi radius squared. After the derivatives, we can easily calculate the derivative differential like this. So, derivative of volume, which is the formula of 4 pi r squared or times derivative of radius. First, we should find out the derivative of volume divided volume is equals to 4 pi r squared Vr divided to 4 divided 3 pi r cubed is equals 3 divided the derivative of radius divided radius. So first we should find out the first formula, which is we can find the derivative of volume. Here is the solution. So the derivative of volume is equals to 4 phi, which is here the volume is 4 pi r squared times 6.255 squared, which is the 6.25 squared is found out the radius squared. The radius squared is equivalent to 3 3.14 times 4 is equals to 12.51 divided 2 is equals to 6.255. Copy the squared. So times 0.01, which is the derivative of radius here. And then equals 4 times 3.14 times 6. Copy the 6.255 squared times 0.01 is equals to 12.56 times 39.155 times copy the 0.01. So the total or the derivative volume is equals to 4.917 millimeters cubed. And then we found we need to find the derivative of volume divided volume, which is the formula is here. And here's the answers. So solutions. The derivative of volume divided volume, which is 3, will be copied times the derivative of radius here. Derivative of radius is 0.01 millimeter, and divided the volume, which is the volume is 4 divided 3 pi r cubed, and it is a 6.255 squared. So the total of derivative of volume is equals to 0.0048 centimeter. Hence, the measured with an instrument that shows a thousandth of centimeter is 0.0048 hundredths, a thousandth centimeters. 0.0048 thousandths.